right, so with a stratified random sample, what did I do with my entire population first? What did I know about those groups? As opposed to here, what did I do with all of my crab legs first? Theoretically here. I didn't look at them as all individual crab legs. I looked at them as clusters. So were these similar individuals? Are all the crab legs on one cluster similar? No. Reflecting the population. So these are not similar groups. They're supposed to be more similar to the population than themselves, or reflect the population. So with the first one, I put them into groups of similar individuals, and then how did I select at that point? So I split it into adults and children, and then how did I select at that point?
They took the same amount of individuals from each group.
And this is very generic. You're taking some from each. Now you take it proportionally to the population, hopefully. It's not always going to be perfect, but the big thing is you split into groups, you take some from every. Now, the groups here, because it's a stratified random sample, are called strata. In a cluster random sample, the groups are called clusters. So here, put them into groups, take some from every. Here, we put it into groups and then do what?
Take the entire group.
And you can take one group or multiple groups. So clusters are supposed to start out looking like they reflect the population, so we take a couple of little ones. So hopefully we're going to have a good representation of the population. Whereas stratified, they're not supposed to look like the population. They're supposed to be similar to each other, but we're ensuring that those similar groups get included in our sample. And neither one of these are the case that all possible samples of size n have an equal likely chance. If I say groups that are similar within, is that stratified or clustered? Similar within. Stratified as opposed to similar between is what? Clusters. You just got to understand that wording. All right, so we've got stratified, we've got cluster. So getting into the whole every possible group of size n given an equal likely chance of being selected. When we had 6 adults and 6 children, and we selected 4, so we selected 2 children, 2 adults. Would it be possible to get a group of all 4 children? No. So that means that every possible group of that size did not have an equal likely chance of being selected from that group or from that population. That's the other example I used. This is one of the most important definitions for our class. And for the first couple weeks, people will get these confused. You will definitely see this on the AP exam. And it is something that you definitely need to know. So a simple random sample is your next one. Which from now on, anytime I write SRS, that just means simple random sample. And don't write all that. So the first one is true because it is a random sample. So I don't really need to write that every individual in the population has an equal likely chance because that's by definition of being random. What makes it specific to simple random sample is that now every possible group of size n has an equal likely chance of being selected. So you just need to write that starting at every possible. So, interesting tidbit here, lottery. You can pick your lottery numbers. A lottery is a simple random sample, so every possible group of however many numbers from however many pick has an equal likely chance of being selected. But if you win the lottery and somebody else picked the same numbers, you have to split it with them. It's like usually when the lottery gets really big, so whoever wins it usually ends up getting split. People who don't understand statistics think that you can't have numbers that have a pattern. Like that doesn't make sense to them. But they all have an equal likely chance of being selected. So in a lottery, the number, if you have 5 numbers that you're picking a lottery, 1, 2, 3, 4, 5 has an equal likely chance of any other possible combination of numbers out there. So if someone were to pick numbers and understood this, they would probably go with something with a pattern because less people would choose it, which means if they won, they would have to split with less people. And that's something that's kind of hard to wrap your head around at first, is something like 6, 7, 8, 9, 10 is actually just as equally likely as any other combination out there. There's one more. It's called systematic. I want to go and get to it. I'm going to pull it up on a different slide. All right, so we've already talked about cluster. Don't worry about that. So write systematic sample. So systematic is like a very particular systematic way about doing things, which is the one that's different. Anything with an assembly line is usually done in a systematic way. But what do I mean by through an assembly line? Like something that goes through an assembly line is what? What? So like what? Okay, a car. So how do the cars go through the assembly line? So they're going to be put in order and go through that line, right? If we want to check and make sure the machine works, are we going to pick the first 100 cars that go through the assembly line and then be done with it? No. Are we going to pick the last 100 that go through? We're probably going to do what? So probably evenly spread out, like going through, so like maybe every 100th. So they were randomly put in order. Then we'd pick a random starting point, and then we'd pick a random number to go by. I don't care. I would shorthand this. Let's shorthand this together. And again, this is another random. You don't have to write the word random, but again, I always have people who, because I didn't write it the first time, they think that it's not random anymore. So they're placed in order. And then you find a random start. And then a random interval to select. So if I want to do this with our class, I could put you guys in alphabetical order, roll a die to see which person I would start on, roll a die again to see what interval I would go by for who I select. And this part right here is kind of funny. Sometimes I can do this with, and I'll probably go over an example. Like if there are 35 of us and I want to select 7 people, it would make more sense to pick every 5th, right? Because 35 divided by 7. And then so I would randomize a number 1 through 5 to see where I would start and then pick every 5th from there to make sure that because of 35 divided by 7 is 5. Questions about sampling. I know I'm going through them pretty quick. I do want to split these videos.